Okay, so this video is about using the quadratic formula. And the reason we use the quadratic formula is to find the roots, and remember the other words for roots are solutions, zeros, or x-intercepts, of a quadratic function. So if I give you a quadratic function and I ask you to find the roots, whenever you cannot factor that quadratic function, then you're going to use the quadratic formula in order to find your solutions. Now, the great thing about the quadratic formula is that you can use it anytime on any quadratic function in order to find the roots or the solutions. So even if I give you a quadratic formula or a quadratic function that you can factor, you can still use the quadratic formula to find the roots or the solutions. So make sure you have your notes out that I gave you for the flipped classroom assignment, and we're going to kind of go through those notes together, okay? So the first thing that you want to look at is the actual quadratic formula. So this is the actual quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the first thing I want you to notice is this x equals. The reason why part of the quadratic formula is x equals is because, remember, we're using the quadratic formula to find the roots. So if I'm trying to find a root, I know that it's a coordinate point, and I'm going to get an x value, and then the y value is always 0. So this quadratic formula is giving you this x value of the root. So the other important thing about the quadratic formula is this expression here that's located underneath the radical it has a special name. It's called the discriminant. So the expression under the radical is called the discriminant. Okay? So we're going to jump right into the first example. The first example says to find the roots of 2x squared plus x equals 5. So I know that this is a quadratic function because of the x squared, and there's no other degree higher than 2. So the first step is to make sure that it's in standard form. And this is not in standard form because this 5 has to be on the other side of the equation with the rest of the equation. So to make this 5 go to the other side, we're going to subtract 5 from both sides, and that's going to give us 2x squared plus x minus 5 equals 0. So now it's in standard form, ax squared plus bx plus c. So step 1 is to just go ahead and identify your a, b, and c variables or values. So the value of a is 2, the value of b is a positive 1, and the value of c is negative 5. All right? The second step is to plug in your values into the quadratic equation. So this is where the mistakes start happening, so we want to make sure we're attending to precision. We're going to do that by starting off writing our actual quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. And it's also really important that you put the entire numerator over that denominator. If you don't do that, you'll run into an error later on. Okay, so again, this part is called the discriminant. The next step is actually plugging into the quadratic. I'm pretty picky about this. I want to make sure that every time you plug into a variable, you open your parentheses to plug in, because these negatives can get a little bit messy with that. So this negative is part of the formula, so I'm just going to rewrite that negative. I see that I need to plug in b, so I'm going to open my parentheses and plug in my b value. Plus or minus the square root of, I see that I have to plug in a b, so again, I'm opening my parentheses, I'm plugging in my b value, minus 4. A is 2, so I'm going to open my parentheses to plug in a, and open another set of parentheses to plug in c, which is negative 5. Extend that radical all the way over. And then again, remember, this is all over 2 times a, which is 2. So if you take a broad look right now, here's the quadratic formula. Here's what it should look like after we've plugged in. So the next step here is going to be to simplify. And I wrote a note to make sure that you put the discriminant in the calculator, and I'm going to show you what that looks like, okay? So first of all, this negative times a positive 1 is just negative 1. And I know that you may see right now that these parentheses are not really needed, but they are going to be needed whenever this b value is negative. So that's why we're just going to make it a practice to always input parentheses when we're inputting variables. Okay, so -1 plus or minus the square root of. So what you're going to do at this step, very important, we're going to put the entire discriminant into our calculator. Remember, when I say discriminant, I'm talking about just the expression under the radical, not the radical itself. So the discriminant is just the stuff that's underneath the radical. So in our calculator, we are going to enter the discriminant exactly how we see it on the paper. So the first thing is 1 squared minus 4, and please make sure that this minus that's in front of the 4 is an actual minus sign on your calculator, okay, not a negative sign. Minus 4, parentheses 2, parentheses, parentheses, -5, parentheses. So this is the discriminant, exactly what you see underneath the square root bar. Press enter and you see that the discriminant is equal to 41. So I'm going to input 41 as my discriminant in the simplification process. Okay, and then remember, this is all over 2 times 2, which is 4. Okay, so we've completed step number 2, which is plugging in and simplifying. So step number 3 is to solve. So at this point, we are going to really examine this simplified form. This says -1 plus or minus. So literally, you're going to have to do 2 solutions here. One of the times you're going to input -1 plus the square root of 41 divided by 4. And then the other time you're going to do -1 minus the square root of 41 divided by 4. So I'm going to write that out here. And I kind of do, you know, a little tree thingy here so that I make sure I see. One of them is, don't forget your x equals. X equals -1 plus the square root of 41 divided by 4. And the other side is x equals -1 minus the square root of 41 divided by 4. Okay? The square root of 41 is not a whole number because 41 is not a perfect square. So I don't know what that is. So I'm going to have to use my calculator to help me. All right? So, and that's a good practice just in general for these until you get really good at them. But always when the discriminant is not a perfect square, you're going to need your calculator. So I'm going to do just the numerator first. Trust me on this. -1 plus the square root of 41, then press enter. Now divide by 4. If you do it all in one step without using parentheses, it'll be wrong. So this one is equal to 1.35, and we'll round here to the nearest hundredth just because that's easier. The other side is going to be a completely different number. Just because this one says plus here and we happen to get a positive number does not mean that the one that says negative here is going to be like -1.35. Doesn't work that way. All right, so we're going to do -1 now minus the square root of 41. Press enter, all divided by 4, and we get -1.85. Okay. So as you can see, we have 2 different roots or solutions. And remember, if I'm graphing this, it's a quadratic. I know it has to open up because my a value is positive. So I'm going to have a root here at -1.85 and a root here at 1.35. So it would look something like that. So what we just found by using the quadratic formula, again, are the roots or the solutions or the x-intercepts or the zeros of this quadratic function. So the way that we express our solutions, because they are roots, is as a coordinate point. So the first coordinate point is going to be 1.35, 0, and the second coordinate point, the second solution, is -1.85, 0. So these are your 2 solutions for this quadratic formula, or for this quadratic function. So the next video is going to be the second example. It's very important that you also watch the second video, okay? Don't skip it and think that you know what to do, because while you may know what to do, we have to talk about these discriminant rules. So I want you to end this video now and go to the second video.